Hello chemistry students, this is the first flipped video where we'll be covering stuff that are directly related to our modules. We'll be looking at dot points 1.1.1 and 3 to begin with, and in this video we'll be looking at physical and chemical changes of matter. So first off, let's look at some examples of physical changes. I've got a bunch of different pictures here to show you some examples. The main thing to keep in mind that is for a physical change, there's no actual change to the composition of a substance. So as an example, if I were to melt an ice cube or boil water, in both of these instances, the substance still remains water. It is still H2O. The chemicals that are present have not changed themselves. There are some other examples here where maybe we crush a can or shred paper, chop wood, or break glass. In these instances, we are changing maybe the shape or the size or the structure of a particular substance. But in each of these examples, the can's still a can, the paper's still paper, the wood's still wood, and the glass is still glass. They are the same substances. There's another few examples here: mixing sand with water, mixing green and red marbles, and dissolving sugar in water, in which we are forming mixtures. When we are mixing two substances together, we haven't changed those substances either. There are still sand chemicals and water chemicals, still green and red marbles that are the same substance, and still sugar is still the same substance when it's dissolved in water, and there are still water particles that are still the same substance as well. The one that I've missed here is sublimation of dry ice. This would probably be most similar to these state changes up here. The dry ice or the carbon dioxide, whether it's a solid or a gas, it doesn't really matter. It's still carbon dioxide. Again, the composition of the substance has not changed. A few examples here are of chemical changes. Now in these, what's happening is that there are changes to the chemical composition of the substance. So for example here, when we're burning wood, we're taking this organic substance that are made of all sorts of different kinds of sugars or things that have been made by sugars and turning them into carbon dioxide, water, and also turning them into solid black carbon itself as well. Now, the wood itself wasn't made of those substances to begin with, but in chemical reactions in the burning of the wood, they have changed. Similar to the rotting banana, it's made of all sorts of sugars as well that are made of carbons and hydrogens and oxygens, and when they rot, they change their chemical composition, and we know that because they completely change in their look, their taste, and their smell. When we mix vinegar and baking soda, again, it undergoes another chemical change, forming new substances. In particular, it forms carbon dioxide gas, which can be seen by the fizzing and bubbling. And when we're doing fireworks, similar sort of thing. We're taking substances and combusting them and burning them, and they form different substances as well. Now, there are different ways to evidence or see that there are chemical changes happening. Now, these are quite common ones. There are other ones as well, but these are some main or core examples. So as an example in my first one here, there are formation of gas, indicating that there's a production of a completely new substance, a gas that wasn't there before. There may also be production of energy in the form of light. Now, that could be visible light, but could also be infrared or UV or X-ray light as well. Any kind of energy, essentially. There could also be changes in temperature. Now, that could be a reduction or an increase in temperature. This is very different from, say, putting water on a stove and putting energy into the water. What we're saying here is if there's been a chemical reaction, there hasn't been a need to, say, cool it by putting it near ice or putting it in a fridge or warm it by putting it to a flame. The temperature change is happening by itself just by putting two different chemicals together, and that can be evidence of a chemical change too. What we might also see is a change in color, essentially meaning that one substance has changed into a different colored substance. And there may be some other versions of chemical change evidence where we may see the formation of a new substance. So as an example here, we have two aqueous solutions, some sort of salt mixed together. We can't see it at all, but when we put them together, we've clearly formed a new substance, not just because of the chemical change, but we can see that we've formed this solid precipitate as well. Now, there is going to be a lot more exploration of chemical changes in further modules, in particular module 3, when we start looking at chemical reactions in great detail. But for now, we're going to be focusing on basic physical and chemical changes, physical ones in particular, and from here we'll springboard into looking at physical and chemical properties in the next video.